In this video, we're going to calculate the frequency of a photon as it moves from the n equals 6 to n equals 1 energy level. So in order to calculate this, we first need to use our Rydberg equation. The way that we solve for that is going to be 1 over lambda, which is wavelength, is equal to our Rydberg constant, r, times 1 over n1 squared minus 1 over n2 squared. And our Rydberg constant is going to be equal to 1.097 times 10 to the 7 meters, or inverse meters. So as we look at this equation, as we move from n6 to n1, we're going to plug those numbers into our n1 and our n2. So it's going to look something like this. 1 over lambda is equal to our constant, which is 1.097 times 10 to the 7 per meter. And now we're going to do our fractions. So we're going to do 1 over n1 squared. n1 squared is going to be 1, so 1 squared, minus 1 over n2 squared, which is 1 over 6 squared. There we are. So now let's solve for this. So if we just do the inside part of our parentheses, well, 1.097 times 10 to the 7 per meters. This comes out to 0.9722. And then if we multiply those together, we're going to end up with 1.067 times 10 to the 7 at per meter squared. Again, this is all equal to 1 over lambda. So if we need to solve for lambda, we'll just do a little bit of rearranging. So now our lambda is equal to 1 over 1.067 times 10 to the 7 per meter, which will then equal to 9.376 times 10 to the minus 8 meters. Now this is a wavelength. We haven't gotten to frequency yet. So we need to go back and use our other equation, which is frequency is equal to the speed of light divided by wavelength. So let's plug in our values. So frequency is equal to the speed of light, which is 3.00 times 10 to the 8 meters per second, all divided by our new number, which is 9.376 times 10 to the minus 8 meters. And this is going to be equal to 3.20 times 10 to the 15 per second. And that's because, as we look at our units here, since we have meters on top and meters on bottom, those will cancel out, leaving us just with per seconds. So for this problem, you need to first use our Rydberg formula, which is right here. Plug in your transitions, whether that be from 2 to 6, 10 to 9, doesn't matter, as long as you plug those in here, solve, and then finally use our frequency equation, which is equal to the speed of light divided by wavelength, and you'll be able to solve for that frequency.